Okay, so the beginning of that video was for Jake and Kenzie, and we'll see how many times that we can say first things first, just for you guys. Okay, so we're going to talk. We're going to start a new unit today, and we're talking about trigonometry. So we're going to jump right into trig functions, as opposed to like the trigonometry that you started with last year. Last year, the trigonometry you started with was like solving triangles, right? And then the second part, you talked about trig functions, about the graph. Okay, we're going to jump right in and talk about trig functions, and recap all the stuff we did in grade 11 with one huge change, and that is the type of measurement that we use. So you can see right now there are two ways to measure angles. What's the way that you measured angles last year? Degrees, that's right. And those are all, we're used to seeing that. We know angles, 90 degrees, 45 degrees, and all sorts of things. But that's not the only way you can measure angles. There's a second one called radians, and that's what today's lesson's all about. So we're going to learn what a radian is, but the first thing you need to recognize is this is just another way to measure an angle. Okay? And the number will look different, and it's thought of a little bit differently, but it's still another way to measure an angle. Okay, so we're going to go off and do almost everything we did last year with trig functions and the graphs, but instead of saying things like the period of a sine function is 360, we're going to change and describe it as a radian measurement instead of 360 degrees. And I'll tell you what that is as we go along. So first off, we have to define what a radian is. So here's our definition. So the radian measurement is the arc length divided by the radius. Arc length divided by the radius. So we're going to start thinking of angles more as rotations as opposed to like corners into a triangle. Although it's the same angle, okay, a corner of a triangle is still an angle, but we're going to also think of them as rotations. And that's where this definition will start to make a bit more sense. So for example, what I have over here is a circle on the Cartesian plane, and I'm going to draw an angle in that circle. So I'm going to start by putting an initial arm right here. We'll define these later. The initial arm is on the positive x-axis. And then I want you to imagine that this arm gets rotated counterclockwise a certain amount of measurements, a certain angle, and stops at what's called a terminal arm. Okay? So it's going to rotate and finish someplace, let's say over here. We consider this a rotation. It's going to be a counterclockwise rotation, starting at the positive x-axis and going counterclockwise. By doing this and considering that angle, you can see that does kind of look like the corner of a triangle, but it's another way to think of angles. It introduces these two other measurements. It introduces the arc length and the radius. So the arc length is this measurement right here. It's the distance around the arc of the circle that your rotation created. For this particular example, let's pretend that the arc length was 5. 5 whatever, 5 units of measurement, 5 centimeters, 5 millimeters, it doesn't matter. So the radian measurement is that arc length, which in this case is 5, divided by the radius of the circle that we drew. In this case, the radius, of course, would be this length right here. It's the same as the length down there. It doesn't matter, right? As it goes around the circle, the radius is going to stay the same. And let's say in this case, we pretend that the radius was 3. And if you take that distance of 5 around the outside edge, the arc length, divided by the radius, you get this new number. In this case, the number, if you divided it, would be something like 1.6666666. We'll round it to 1.667 radians. Okay. So instead of saying that angle is, I don't know, 50 degrees, we say it's 1.67 radians. And regardless of the size of the circle, the relationship between the arc length that it creates divided by the radius of that circle is always going to be 1.67 for that particular angle. So if I looked at it down in the smaller part, and I just looked down here and said, oh, I have a smaller radius, well, of course you're going to have a smaller arc length, right, if you had a smaller circle. But the ratio between the arc length divided by the radius for that particular angle would always be this. Okay? Now, right there, we could go off and the textbook asks you to answer a whole bunch of questions just with this, but that's not really how we use it most often. We use it more often when we talk about full circles and degrees versus radius. So we're going to next be able to talk about converting from degrees into radians. Since you're comfortable in talking about degrees, we need to be just as comfortable to talk about radians. And going back and forth between the two. And to do it, we're going to consider a full circle. So when we look at a full circle, let's first think about it in degrees. What is a full circle in degrees? Right, 360 degrees. Let's consider the radians of a full circle, okay? So the radians, remember, apparently is the arc length divided by the radius. Now we don't know how big this imaginary full circle is, so we're just going to consider it in general. So first off, the arc length of a full circle starts in one spot and goes all the way around the outside of a circle. We have another name for that measurement, the outside edge of a circle. Circumference. Yeah, perimeter, you're right, but for a circle, it's got a special name, circumference. Does anyone remember the formula for circumference of a circle? 2 pi r, yeah, good. Okay, it's 2 pi r, okay? We don't know what the actual radius is, so we're just going to leave it as r. So since we don't know what that is, it doesn't really matter, though, because the relationship's always going to be the same. What's 2 pi r divided by r? Well, we have an r on the top and r on the bottom. And we get 2 pi. Now, what I want you to understand is that this is an actual number, okay? 2 pi is 2 times 3.14156, blah, 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 blah. So 2 pi is actually about 3.28, or sorry, 6.28, right? 3.14 times 2 is about 6.28. So a full circle, a full rotation, we say is 6.28 radians. But we're not going to write down 6.28 because, one, it's not as accurate because there's a whole bunch of other decimals down there. And it's going to be annoying. So instead, we're always going to leave it as 2 pi. Okay? So our first big learning is this, that 360 degrees is the same as 2 pi radians. (360 degrees is 2 pi radians. We know it's around 6.28, but we're not going to say that. We're going to say 2 pi. Okay? And all today is getting used to that and using it in different angles or situations. So the first thing I'm going to think of is if a full rotation is 2 pi, what's half of a rotation? 1 pi, that's right. And what's half of rotation in degrees? 180. So the other thing we can do is say 180 degrees is pi rads, or radians. And these two ideas are the basis of radian measurements. Pi is 180, or 180 is pi, and 360 is 2 pi. Because of this, we can use this to find all sorts of other conversions. Okay? So we're going to start with the pi equals 180 statement and look at two ways to do conversions. So the first thing is this. I'm going to take this statement and I'm going to divide both sides by 180. So I'm going to take pi equals 180 and divide both sides by 180, divide both sides by 180. And I'm going to get 1 degree is equal to pi over 180. That will be useful when converting from degrees to radians. And we'll show an example in a second. But if you know that 1 degree is pi over 180, then 2 degrees would be 2 pi over 180, 3 degrees would 3 pi over 180, 180 degrees would be 180 pi over 180, 180 over 180 is just 1, and you just be left with pi. Okay? So that we're going to use when converting from degrees to radians. We're going to look at using this a different way. And instead of dividing both sides by 180, I'm going to divide both sides by pi. So I have pi equals 180. I divide both sides by pi. And of course, over here we have 1 radian, because pi divided by pi is 1. And we have 180 over pi. And we're going to use this when converting radians into degrees. And we'll do a couple examples in a second. But if 1 radian is equal pi over 180, then 2 radians would be 2 times 180 over pi. And 3 radians would be 3 times 180 over pi, and we would go from there.